started on the next segment here. That's I think everybody's just waiting back there. I'd like to introduce myself. Tom Dillard from the Wasmer Company. My interest is in HVAC. My background is spent about 16 years so far working in HVAC and took a state apprenticeship, became a steam fitter, and I liked doing all that, but what really piqued my interest was energy efficiency. And I'm pretty passionate. I mean, I work long nights just to try to maximize the resources that a customer has on site and repurpose them. It's really something that fuels me, and I think that's why it's a great fit working with Wasmer as well. They have the same mindset. So, if we can do something like that and also refine your process, that's all a win-win. So after looking at the energy report too, that's something they're looking at with the furnaces. It's when I first went into that Burlington plant, it's the only one I've been to so far, but it just blew me away. I've never seen a furnace that big. So I couldn't imagine what it took to actually figure out how to make that all work. It's very humbling. I bet. You know, it's when you talk about trial and error, I'm sure there was probably a lot of that in the early days, trying to figure out how do you make this process work properly, and then looking at the slugs coming down the machines, you know, and going into the castings and how that's all timed properly. It's just to really have appreciation for what that all takes. I think from my auto mechanic days, you know, years back, and then doing HVAC, it's really amazing. I have a lot of respect for what you guys do, engineering-wise, and I think that it's a great place to start for sure. Trying to look at that stuff and do you some justice as far as saying, hey, let's bring some solutions that can maximize what they've already done and hopefully improve it for the future. So I was really doing some research as well, and I don't think I have my facts 100% straight from the website at Ardagh, but initially I was saying on the website 81 facilities and 21 countries, 19,000 employees. I was thinking, geez, this the sustainable impact that the company can make by refining a process. And it looked like Limerick, Sweden, the project that it went on there, where they're actually taking the heat from the furnace and they're supplying it to the town of 10,000 people, or 5,000, excuse me, and they're heating the entire town with the heat off that furnace. And doing the same thing, a similar thing it sounds like in Denmark, from some of the research. So I looked at Burlington, it's about 11,000 people. That's high hopes, but it's one of those things that, along with your initiative on the website, it's talking about to have one meaningful community project at every Ardagh plant by 2017. I mean, I think that if you have to start somewhere with a mindset and have the people behind it, I mean, I think there's no better place. So I just think that coupled with the fact that you already have great minds working here, I mean, I think that even if we did something on the plant level, it would be pretty amazing to take a lot of the heat in that furnace and utilize it for other areas. So. Also, what I like to read verbatim on the website was you guys basically state we have a reputation in all markets for innovation, pushing the boundaries of what is possible, pioneering new production methods, new design techniques, and new ways to recycle and save energy. That's just like basically exactly what Wasmer, that encompasses everything that they believe too. So the alignment is perfect. Everybody's here. I mean, I'm really honored to be here, coming from Wisconsin. It's one of those things that it's a little bit bigger than I'm used to as far as you know, in speaking terms. I'm not an engineer, but I am a little crazy when it comes down to my ideas, and I think you have to be to innovate. So we've had a lot of cool ideas work out, and I think that there's a platform here that really is amazing. So. Really, I think that the employee morale at the Burlington plant was one thing we really wanted to hone in on. And that did have an effect on some of the things we're thinking about. So I heard just a little bit about the energy reports, and that's not really performing the best. I think that's not really quantifiable necessarily when it comes down to people coming and going. But if you clean up the environment and you take that to a different place, people become happier, they see things being done. And in a whole while, you're actually using that same technology and that same process to improve your spend. I think that's where we're going to try to take this. So when we talk about just a couple of things, an overview of the heat recovery, heat pipes is something we've done successfully. I don't know if anybody in the room's heard of heat pipes, had any experience with them. Really cool technology. It's one of those things that it says right there, thermal transfer devices capable of transferring heat and energy several hundred times faster than conventional methods. I would look at conventional methods like a shell and tube heat exchanger, where you're using convection. Where we've really looked at the similarities is an air conditioning system, where you have a DX coil with a metering device using a compressor, but you have a latent heat transfer that is actually absorbing that energy and releasing it. So it does exactly the same thing, but it doesn't use any energy. It's all doing it passively. So the thing that maybe helps put into perspective a little more is this little diagram here. When you see on the A, you're seeing basically your refrigerant sitting in the bottom. It's absorbing the heat, and then it's called the evaporating section, just like a refrigeration system, and boils it off to the vapor phase, and then it's released from the upper cylinder. After it does its job of removing that heat to another area, it condenses to a liquid phase, and then by gravity it returns again. So such a simple process, but anything you can do to have this entire thing happen without having to spend any more money beyond initial investment, I think those are areas that we're looking to maximize. So one thing we were thinking, winter-only recovery, when you just look at cooler outside air and warmer exhaust air, there's a lot of extra heat because of the furnaces that's hanging up in the ceiling. And if we even were able to capture that through a heat pipe, with 100 foot of equivalent horizontal separation on the piping and 50 feet vertical, it gives you a lot more latitude than a standard shell and tube or something where you're using at point of use. So these guys will come out, they partner with us, they don't let us charge the system, it's a proprietary process. It's a standard 134A refrigerant, but they put it together, and when they charge it, they don't let you in the area because they want to basically keep that secret to themselves. But after it's charged, it's sealed, and you never have to worry about it again. If it leaks, I believe it's lifetime. They come back and recharge it. So it really, a lot that they've done, there's a lot of case studies out there in a lot of different countries. They've been using it. And it's also great for dehumidification, along with really, I think healthcare they're using a lot in too. But I think with process like you have, it'd be a perfect fit. Another kind of diagram showing just basically what they're doing, warm exhaust air and that cold outside air, all that happening passively. So no energy inputs required. So really it just kind of states again on the bottom there how you liquid to vapor back to again. So that's really the phase change that's doing all the work. And we could look at the liquid, the wet side of heat recovery, and then also the air side of heat recovery. All the air that's up in that ceiling above the furnace is pretty dirty though. And I think that might be one of the biggest concerns that you have about repurposing that air. So how do we look at that and make that useful? This is kind of a larger term, but I think everybody knows electronic air cleaners pretty well. Don't use a whole lot of electricity. Do require some maintenance when it comes to cleaning them. They have a blower. They don't have to have a blower. You can use a blower downstream. A metal mesh pre-filter. It's trapping the dust particles. And then you're basically charging the particles and then passing to collector plates. And pretty easy to see right here. It's a very basic design. So if we are implementing some of these in the plant, proven technology, something that can be on a regular PM schedule, we're going to be able to filter that air out and send it where we need to send it without having to worry about contaminating other areas or other parts of the process. I'm not really just here to train. Obviously, I really want to learn from you guys too. If you've tried some of this stuff in plants, if you've seen obstacles trying this type of technology, and can anybody offer anything to that? Haven't seen it done, hey? Even in the respect of information sharing, you talk about Sweden having this heat exchanger that's capturing all this heat. The fact that that's all part of the same company, the blueprints must be there. If they're willing to share the information, I mean, talk about engineering time saved and looking at a working model. That's stuff that Wasmer is willing to invest to go to that plant, take a look at what's being done there, and duplicate the efforts. So that's one big part of what Wasmer does, is they invest a lot of time and energy on the front end to develop a long-term relationship and solutions that other companies might just say, well, this is too much effort. We would love to have something of that nature to sink our teeth into. So if anybody would know anybody on the corporate level that would have access to somebody over there, and I did some research, I couldn't find anything online. I don't know what type of heat exchanger is even being used. Something obviously that can take a lot of heat and not melt down, but it's one of those things that will really be exciting. A small diagram here showing the air cleaner up top. Basically, that's the Burlington plant, how it has that lip coming off the top, and then you're cleaning the air and sending it downstream. Now, there's a lot of areas in that plant that are using temporary heaters right now, which you're paying therms for. They rent them, you have rental fees, you're paying to hook up gas to them by meter therms, and all this heat that's sitting up there can be reused, so it's really a large savings. Looking at the pie chart, it wasn't a huge amount of heat savings there, but the fact is you're only paying for it once, and then you have some continued maintenance, but it's not like putting a new piece of equipment in and saying, well, let's just put a unit heater in over here and just let this suck gas all the time too. You're not really getting anywhere to a better place, and all that heat's still going up the stack and going out the top. So it's also stratification that I think we can leverage there. So when you talk about stratification and temperature layering, naturally or artificially generated, definitely something that's happening there artificially generated with the furnaces. We love to use the destratification. Redirecting that hot air from the ceiling to the floor. When we looked at the basement of the plant, there's a lot of water dripping down there, and I think that's a major concern in the wintertime because of the fact that it's freezing up and causing safety issues. And there's, I think, 5 or 6 heaters that are put down there all winter, just blasting away. A lot of air moving out of there. The furnace is using a lot of outside air for the process, but simply pushing the air down from the furnace and reusing it in that basement was something we're looking at designing. We're fairly close to proposal on that. It's one of those things that it's so close to where you need to use it. So we really thought that this would make great sense. And there's a couple different ways of looking at that. If you looked at the diagram of the heat pipe, where you have a coil upstairs and a coil downstairs in the basement, all you're going to have is an air handler in both sections, not more than 50 feet of pipe length there. The issue we saw was everything in that plant is basically taken up as far as space, so take a duct and try to run it through that catwalk without interfering with the process is going to be pretty tricky. You take a pipe and run it through there, it's not as obstructive. So having the ability to use something maybe inch, 2 inch with the refrigerant charge and transfer that many BTUs really would make great sense, and it wouldn't take a whole lot of work to run it through there. That was something we really wanted to price up as well. Between that or using the destratification technique with there's parafans, about 2,500 square foot spread on these fans that really make a big difference when you talk about the typical high volume, low speed fan that you see people selling out there. Have a lot of restrictions when it comes to space, maintenance. You can't really put that in a place like this because someone's going to get hit, and it just takes up too much room. But you put something like this in there, it's basically going to be tied into the Rockwell system where you're going to have a schedule on it, and you're going to be looking at the temperature up top and below, and it's going to be smart enough to understand if it needs to run a certain speed or not. So once you get that air down where it needs to go, you take another fan or a distribution system down there and you blow it where it needs to go. That's one way of looking at it because of the fact that the schedule is web-based. It's expansion. I don't know if there's anything in the plant right now currently with an automation system, but they look at that about a 15% savings normally. If you can look at something and schedule it where you didn't have that ability before, it's a lot more efficient. And you can add a lot more to that. When you talk about sending air out into the plant, it's no good if it hangs up in the ceiling either. So if you're adding 100 of these all throughout, it's really going to be a lot easier to wirelessly mesh the entire network. Also, if you have a heat recovery on site, which we're conceptually putting together, you have a storage tank, you capture the heat with the heat pipe, and you pipe this to the different areas that are too far away to send air. But you insulate the pipe and you send the water to the areas you need to with point-of-use coils. And you use that heat a lot wiser, also heat domestic hot water. Something very easily indirectly you can heat with that as well. So infrastructure is definitely a large investment when you talk about that, but when you look at the long term, if that plant's been there 100 years already, you're investing a lot of money. It sounds like putting new furnaces in there. It's a drop in the bucket compared to what the $10 million it takes to rebuild a furnace. It's probably small dollars when you talk about putting an infrastructure that's going to benefit you for years and years to come. So a couple different ways of looking at it, and that's kind of what I was hoping to get a feel for is if you've done anything like that, and if you, I guess, like the idea, or if you think that it wouldn't work for certain reasons. Yes?
They've actually done something like similar to this in Seattle,
Okay.
where they're actually recouping temperature from above one of the furnaces, pushing it into a packaging building. And they're getting a lot of heat, so it is a viable concept. Whether it was an elegant solution, I wouldn't say it was very basic, simple and basic. They don't even use electrostatic reciprocators. All they do is use filters, and it seems to work. It gets away from coal fire. Seattle is not a high heating load, so other facilities would far benefit for it. But because they had moved the furnace from a building, they avoided costs and they used old infrastructure to come up with plans that actually work pretty well.
This is wonderful. Thank you for sharing that. It's something that climate-wise, like you said, is a lot further off, but the idea still remains the same. The fact that you have a working model makes it a lot easier to push through.
Just something else to consider, more prevalent in winter, but we stream or gob into the basement, create a lot of steam, and every time you can't see the hand in front of your face when you're walking down there, everything would burn some of this hot air out of the basement all the time. So we want to go out gob in the basement might help in that area.
Absolutely. And that's where the automation would come in handy. If you knew that was interlocked, you'd be able to accomplish that without having to manually do it. That's an excellent idea.
What's the BTU rate for that heat pipe thing or whatever?
It's actually customizable, so it depends what size you get. So they build it basically to your specs. There's wraparounds. There's a number of different, HPT is the company that makes them. Basically, whatever you want, they come out and engineer. So the BTU rating can definitely be all over the map. I couldn't speak to exactly what it is. The application we used was a healthcare facility where we put a coil in front of the DX coil and a coil behind it. So we mitigated the cost of reheat on the VAV boxes because of the fact you're bringing hot outside air in, you're absorbing the heat into it, your DX dropping it down, and then you're going back and re-inputting that back in, and that was 75 tons of chiller attached to that, so it was able to easily accomplish that. But they had to build that coil and they came and installed it for us.
Pricing up that heat pipe thing in Burlington or something?
Mm-hmm.
So I guess shortly, eventually, somebody plan maybe will get a pricing on what that is versus rent owning an LP or natural gas forced air heater, right?
Absolutely. And when you look at that rental, using the BTUs, never ends.
It never ends, but what's the payback on this heat pipe thing? Is it 10 years or is it 2 years?
You're actually,
By cushions, because there's times we want to chill more cooling.
you know, I don't know that you could do it in reverse with cooling cycle, but I suppose you could, because you can absorb the cold air and you can send it somewhere else. It's,
Cold air.
You know, there's other opportunities too, and I think it's often overlooked, is over each one of the IS machines, forming machines up along the core, there's a huge rejection of heat over the IS machine that can either be utilized to preheat compressed air, preheat other utilities in the area, or even send it for heat. You know, it's one of the areas never looked at. There's a huge rejection of heat as we're cooling the blast from roughly 2,000 degrees down to 1,000 degrees in a 10-foot area.
Yeah, but David, the big challenge on that would be collecting it all.
Yeah, exactly. I'm not saying we have a solution, but you're right. But if you walk on the decks above those,
Oh,
those
gosh, yes.
lines, there's plenty of energy.
That's where I hang out.
Yeah.
It's a
I
lot easier.
think that's, Tom, that's the area you were talking about with the purifying the air, correct?
yeah, I didn't know if it was referred to as the IS.
Are you talking about the
Yeah.
furnace there?
I'm talking about the furnace and.
Earlier, I think it was a couple slides back, because that is something that we've been discussing, and that's more or less the issue on the forehearth area is with the mold release agents or what's going in there is the air quality that's up there.
Well, a lot of times you bring in the air and you just pipe it from one end and you just it's heat exchanger. But they're right. There's also a lot of other important functions in the area you can't just get in the way of there.
Right.
That's where you have some latitude as far as what you can design. You know, the payback on it, from what we've seen, these guys work pretty cheap, and we're very happy with it. It's $30,000 to put 2 coils in. And I don't know exactly what the, you know, kind of what the payback was. I was, you know, basically working with them, but not calculating. I'm not doing the calculations. I'm more on the mechanical side, so, yeah.
Yeah, there's another huge opportunity in our cooling water that we use on our furnaces. It runs in the 120 to 140 degree range. We'd really like it to run at 50 degrees. If we can reject the heat other than a cooling tower or a heat exchanger, why not use that energy in the plant? 120 to 140 degree water has plenty of energy to heat a space. And how many gallons? 50, 80 gallons a minute?
Oh, yeah.
Yeah, at least.
And that might be, you know, that's the thing, is the opportunity right there would be something that's improving your process, but also taking the BTUs out of that would be probably fairly easy to do with something of this nature, because of the fact that it's already closed loop on one end, so you do have scaling issues, but if you're not so hot, you're probably gonna be okay with that. But definitely a lot of waste going down the drain right now, right? So
I
that's,
would love my cooling water to run at 60 or 70.
Where are you at? The energy or with cold water?
Both. Colder water will make my chargers last longer.
you take colder water and to your process, and then you use the heat to heat your domestic. Or help a different process around. A lot of that's, like I said, on my end, I need education about what you exactly would like to do with that, but that's huge right there. You know, just the fact that that's an opportunity, we're willing to explore that and put that together because of the fact that we're partnering with you. It's not gonna cost you, we're gonna work with you on it and figure out what it's gonna be, and you're not gonna spend money on it until you say it's a viable solution. If it's 20-year payback, obviously it's like, what are you doing to me here? But that's not the kind of stuff we're looking at. I really think that it's definitely gonna be dynamite, for sure. So,
You guys use wet film heat exchangers on drains?
I'm not familiar with that. What is it that essentially the,
The wet film is if you're draining hot liquids. I mean, you got a vertical drain pipe because of whatever, I mean, anything that's in the liquid, you actually, if you look at the inside of that pipe, you actually will hug the wall, the inside of the pipe. A wet film heat exchanger is a copper tube that's actually soldered to the outside.
Mhm.
So whatever it is you're using that's hot water, you'll actually backfeed the fresh water through the outside tube. It takes the heat transfer from the liquid that's going through the drain, so you preheat whatever it is whatever you would, if you're going to a water heater, whatever.
It's awesome.
So what did you use that preheated water for?
It's, they're used in governmental, housing complexes, they've got them, in industry, we were looking at using it for, the drains off of cleaning, flat glass windows.
Warm houses in Sweden.
What's that?
Mhm.
Warm houses in Sweden.
That's right.
You can buy, you can use it in your house, I mean, anything that, if you've got a collection, it takes 5 feet of vertical space.
Actually use that in my
It's a wet
house.
film heat exchanger.
I thought it was a sidearm, but I use it to heat my domestic water out of my wood boiler, so same exact concept. You're talking about, except mine doesn't have much surface area, but
I know some HVAC companies in Kansas that are using them, I was with them down a month and a half ago, so.
that's another great idea if you look at that at point of use and you have a place to put it. So it does come down to sitting down and figuring out what you need to do, and where you can benefit from it, so.
Yeah, what we find is in the glass industry, everything's so hot, there's lots of low-grade heat sources, but how can you use it within the facility to get all the function you really need to have done?
Right.
The best one that I ever heard of actually was at Seattle. They had so much hot water and could generate steam, they're gonna try to feed the local cardboard factory and it just never went through.
You're doing it in Netherlands, the Coca-Cola plant next door. And, that model's out there too, it depends who's close. But there's a manufacturer that's next door, you're selling that back to them, I'm sure. And that's a lot more limited infrastructure than you're talking municipality, of course. That'd be something that you would have to definitely have the right people in place, but, I think that would be really the biggest play is using it off-site for the most part, because the amount of BTUs you have there, I'm sure Burlington doesn't even know that you guys are, because you're doing that oxy plant next door, right? That's not all coming off the gas meter. You're using some therms on the natural gas side, but majority you're producing yourself. They may not be aware that there's that much heat sitting there. You need to get the right people involved, and the article I read about the plant was basically, it does take a couple different elements. You have to have someone that cares in the area that's willing to work on that, and the plant has to definitely make concessions towards it, and a lot of people have to put a lot of effort towards it. But if you could set up some scenario like that, maybe not in Burlington, maybe somewhere else. It's been done, several plants already. I think that's probably your biggest play is taking that and selling to somebody else. Because right now it's a huge part of what you're spending on. And I'm sure that if you look at payback on that, the dollars spent versus what you get back on the infrastructure cost would probably be a lot closer than just about anything else. Because it's a lot bigger piece of that pie. Focus on energy probably doesn't have the ability, and I think it comes down to maybe someone on the governmental level that would look at that and say, hey, we can try to push this. It'd be something we'd be looking to talk to somebody about for sure.
This has been looked at pretty extensively in Madera, California, on our last rebuild there. There's a company, an engineering company that wanted to tap into our exhaust system there, and to give them that footprint, that was a lot of real estate to give up. But it was a winery right next to us that we service, and but the thing is, for them to make the investment, which is sizable, they want a long-term contract, and basically what they were going to give us was, I can tell you about $100,000, okay, a year, and we said, to risk a long-term contract with a company like that, and we have to supply them with, the temperatures they're asking for to operate their boiler and generate energy from that. We didn't want to make that deal.
Sure.
But, again, we've looked at this pretty extensively.
Nice.
But can we use it in our own facility? Maybe that's a better play than having another company come in and create a venture with with them, you know.
Sure. Yeah, it's kind of dicey, there's too many different parties involved, and
Yeah, but to give them the real estate that they wanted behind our furnace, that wasn't gonna happen. Because of expansion that you might wanna do later on down the road, or just, you know, for accessing our facility, you know, for rebuilds. So that didn't work out.
yeah, that's awesome, I appreciate you letting me know about that. It's one of those things that, you know, even on the wastewater side, is looking at that Samoa plant, and they went from 420,000 gallons a month down to 21,800, I think it was, just by basically looking at what they were using. I guess they were tapped into Sunkist as well, they were sharing water resources, and no one really knew what was going on until they started measuring it. So there's a lot of things that, when you're looking at water usage, especially in California, I'm sure it's, the shortage out there is one of those things that you could definitely get a lot of buy-in on that. Maybe if it was something else, you know, they looked at, but we're open to all opportunities that way. And you're looking at metering water, that's pretty easy to do. So when you talk about what's something that's really going to be, as far as metering it out to somebody as well, when you're talking about heat, and you calculate what the BTUs in that water's worth, and there's a lot that has to go into that. But maybe a possibility if you have the right, you know, the perfect storm happening there. Thanks for all the input for sure. It's awesome. This is something else actually that is exclusive to Wasmer. We've definitely, Tim's been working on it along with myself, and maybe not the best application in every place you go, but it's very versatile. So it's pretty basic too when you look at what it's doing. You basically put a controller on here that's going to be connected to other controllers if you want it to be, or run standalone. And you can use it as heat rejection. My thought on heat rejection at some plants would be having a heat pipe coming outside that heat rejection piece right there that would absorb the heat going out and put it into a tank. But it's intelligent enough to know what the outside temperature is and the floor temperature, and it's able to make decisions based on that when you talk about heat rejection. You could always use it for ventilation. If it's cold enough outside to cool the area or better ventilate the plant, it knows to bring that air inside and do that. Fairly low investment to install it.